All right, Unit 5, Lesson 1, degrees and radians. This whole lesson is nuts and bolts. So it's all of the basic building blocks that we're going to use to add to in order to do trig and move forward. First thing, we're going to kind of reset our definition of what an angle is. So an angle is a rotation of a ray about its endpoint. Starting position, calling it the initial side. And then you have the terminal side. That is a vocabulary word you need to know. Terminal means ending. Without being insensitive, terminal cancer. I need you to know the word terminal. Airport, terminal. End of the road. Not like in life, just in your ride on the airplane. Okay? Vertex, we know, is the point in the center. I explained to you that when we talk about degrees, your point of reference is always going to be the vertex of the angle. So that's where you are standing and measuring how much you are turning. Big idea there. So, in this unit, especially, till we get to word problems, when we start at the positive x-axis, that's always going to be the initial side of our angles. So even in the unit circle, didn't we always start from here? That's where I said you were running a circle from here and going around. That wasn't by accident. You will always start on the positive x-axis, and you will rotate up to the left for a positive angle. Okay, so we're going to rotate to our left for positive angles. So as you can see, if I do a full revolution, you don't actually see an angle. You're going to need to draw this little swoopy arrow to indicate that I did a complete circle or turned 360 degrees. Over here, this is the angle 180 degrees. Notice the little swoopy is back again. Okay, well, swoopy. Now, we also can talk about negative angles. Right? The general rule is this. From starting, left is positive, to the right is negative. So, this yellow angle could be 90 degrees if you draw the swoop on the inside, or it could be negative 270 if the swoop is on the outside. Same thing here, positive 270 with a 3/4 rotation around the circle, or negative 90. Something new. Did you do negative rotation in geometry? No. Rotation is important, positive and negative in physics. Those of you that are going to end up going to physics, it matters. So there's like this thing called the right-hand rule. When you apply and torque happens, it always twists to the downward direction. Something weird that just happens with metals and whatnot. So they're going to talk about which direction that something is in fact turning. All right, so our axis values. We went over all of these already yesterday. These are our degrees. Negative rotation. Okay? Positive 90 is not the same thing as negative 90. But where the jump happens for you all is positive pi over 2 is not the same thing as negative pi over 2. And we will be dealing with negative radians. So that's why I've introduced the unit circle. I want you to get real familiar with those locations and be able to convert them to degrees. Some of you will always think in degrees. You'll convert to radians, but you'll always be doing your calculations in degrees. So an example of that would be this. If I tell you about 3 pi over 4, there are some of you that are going to see this as 3 pi over 4s, which are 345s. If it's positive, that means I would open up 1, 2, 3. If it's a negative in front, I would open up 1, 2, 3, which puts me down here. So you won't actually ever calculate in actual arc lengths. You're going to convert to degrees. That's okay. Right? Some of you will be able to do the radians and count arcs. Rotation. Where would I draw 280 degrees? Well, I would start here at the positive x-axis. If I rotated halfway around, that would be 180, 270, a little bit more, draw in my swoopy. 280 degrees in the positive direction. Negative 195. Again, always starting in the positive x. Halfway around is 180. An extra 15 is going to be the negative 195. Yes? Swoopies are fun. All right, now you're going to be asked to do a couple things. You're going to be asked to draw the angles And you're going to have to answer the question, which quadrant the angle falls. Now, when you read the directions, there are some of you that are very good at listening and watching what I'm doing, but you don't internalize what the directions say, so when you're asked to do it again, you're like, what does this even mean? I'll say, remember we did this? Oh, yeah, I know what to do now. You have to make the connection. So here's one of those places that I want you to highlight. The standard position. A standard position angle means that the initial side is the positive x-axis. That is always your starting location. That's what that means. So if it says draw an angle in the standard position, that shouldn't cause you panic. You say, oh, I already know how to do that. That's how we do all angles. That's what it means. There are times we don't use the standard position in word problems for calculating things like bearing, flying a plane, turning left and right, things like that, driving a boat. Isn't it weird to say driving a boat? Do you actually drive a boat? You steer a boat. Steer a boat? Row a boat. You let somebody else row the boat. Whatever. So, do we all know the quadrants? Just as a quick review. Quadrant 1, Quadrant 2, Quadrant 3, Quadrant 4. 45 degrees would be here. The answer would be that it falls in Quadrant 1. Negative 125. Initial position here. Running around. Quadrant 3. Quadrant 3 is where the angle falls. 495. What? 495. Well, 495 is going to be a lesson in the Olympics because I'm sure you've seen a figure skating competition. Has anyone never seen figure skating on television? You've never watched figure skating in your life just because it never has been on or you had no interest? Or no, your parents? Nobody ever watched? Nobody? No? All right, how about like the X Games? You ever watch snowboarding? Never?
I watch all the Olympics.
Yeah, but no? Snowboarding? Okay. So is there anyone that's never seen figure skating or snowboarding competition? Anthony, never? How about, do you watch like street dance competition? That was a little personal. Okay. All right. So those of you that have never seen any of them, this is going to be totally new for you. But we actually can measure degree of turn for more than one revolution. So if you're watching the Olympics and you're watching figure skating, you'll see them jump off their skates on the ice and spin up to 4 revolutions. I think that's the most anyone's done. Quadruple. 4 revolutions in the air before they come back and hit the ground and keep skating forward on that tiny little blade of ice. I mean blade of whatever that's metal. I don't know how they do it. I don't know how their ankles don't break. It's amazing to me. But the point is that if I am about to take off and spin and I'm spinning to my left, that is my positive direction. If I'm spinning to my right, it is my negative direction. And you can have angles that are significantly higher than 360. So at 495, I'm going to start here. I'm going to do a full swoopy revolution, 360. How much more do I have to go? 135 degrees. So then I'm going to keep going, 90, that puts me right here. Bring my swoopy around to there. Now, I want to introduce this right from the beginning. I found this is the best in terms of learning. 135 is known as our reference angle. The reference angle is the unit circle value that falls between 0 and 360 or 0 and 2 pi if we're talking about radians, that lands at the same spot. So if I'm standing in the center and I'm rotating, I could do a full revolution and come back to 495, or I could just go 135 and end up there. I end up looking at the same place. This is known as the reference, not the reference angle, coterminal. We're going to get that in the next slide, the definition. All right, as I said, nuts and bolts. Here's some more. When we talk about angles, somebody got the grand, wonderful, great idea that let's take 1 degree. So I'm going to blow up 1 degree. We all know this is more like 45, but pretend it's 1 degree, and you can divide it up into 60 parts, which are going to be the minutes of the degree, and then each one of those minutes can be divided into 60 seconds. 1 degree. Like legit, like 1 degree gets split up this much. Okay, the notation for that is the little apostrophe. 1 of them is going to be minutes. 2 of them is going to be seconds. Degrees, minutes, and seconds. I was told, I don't know the accuracy of this, that it came from, this is my folk story for you for the day. It came from, imagine like back in the day, like Christopher Columbus and pirate ships and all that good stuff, and they had those big wheels, right? When you're coming across an ocean and you're going large distances, don't you think fractions of a degree make a big difference where you're going to land across an ocean? If you're off by like half a degree, it could be like Florida to New York. This would be written as 61 degrees, 27 minutes, 42 seconds. This is the shorthand version of this. From this moment on, if I give you calculations in DMS, degrees, minutes, seconds, you give me answers in DMS unless I'm telling you to convert. So you don't want to go to decimals. These are not decimals. Okay? What I want to liken it to for you is if I told you I want you to come back in 3.5 hours, right? That would be what, 3.5 hours? You like decimals? However, that would be what, 3 hours and 30 minutes? If we're talking 3 hours, 30 minutes, please don't tell me 3.5. Stay in this form unless I tell you to go to decimals. Okay. So then we have decimal degree form. Decimal degree form is like 3.5 hours. We can take this 61, 27, 42 and convert it. Notice that those numbers have nothing to do with the decimal. What I'm saying is there's no 2742 that this becomes after that. You have to convert it. So now we're going to do a calculator investigation. Pull out your calculators. As you can see in your notes, I'm going to ask you specifically to convert. Here it is. Underline, convert. This is the only time you will be changing forms. So I want you to try to figure it out so that you can imprint the skills to find this in your calculator. I'm not going to show you, but I will tell you that you will need to use the angle menu. The angle menu is right here above matrix, I believe, for most of you, unless you have a different version of the calculator. You are also going to have to use this little green symbol above the plus sign. That's the minute symbol. So see what you can do. Put it in, try to figure it out, see if you can get it to give you answers and convert. So again, I reiterate, please do not use the degree symbol when you are inputting values unless you are putting in a full DMS. All right. Here we go. If you've been checked out, time to check back in, because this is going to help a lot of you memorize your unit circle. I said this yesterday one time. This is now the second time I'm saying it. Given radians as a fraction, the denominator tells you how many parts per semicircle. So my example here would be if I had 7 pi over 6, I need 6 parts per semicircle, which tells me I need to go 1 more part beyond. Also, anytime you have improper fractions, it's more than 1 semicircle. It could be in the bottom semicircle or going around again, but anytime it's improper, you are definitely more than pi. So the 2 examples you have in your notes are, hello. Oh, hi. Let me guess, period 10?
Yeah.
Yes.
You got candy though.
Oh, that's no problem at all. Thank you. Dreaded pink cover slip. Every time I go in, every single time, the kids are like, "Are you a substitute?" No, sit down, be quiet. Every single time.
You're kidding me.
Every time.
It's
Like,
a freshman
how do
class.
you miss this? This is what white girl walking around the school like, you never seen me before? Ever? How many of you never saw me until you came to this class? Oh, Lord.
I saw you.
Case in point.
Yeah,
Probably because you're up on the third floor so much.
What? Yeah, and I just go down in this little hole in the basement down there in King
Yeah.
Row. Those of you who have seen it, it is not exciting. All right, so 3 pi over 4. The denominator tells you how many parts per semicircle. So that tells me that in my semicircle here, I've got 4 parts. I'm going to travel 3 of those 4. 1, 2, 3 puts me right here. Ooh. Now I've thrown you a curveball because I've given you negative 7 pi over 6. Negative 7 pi over 6 means we're going to start here at this x and we're going to travel in a downward direction. There are 6 parts per semicircle, so there's 3 in the first, 3 in the second, which means I have to go 1 more part, which puts me right here, which is this short triangle in quadrant 2. The short triangle in quadrant 2 resonate with the picture you have in your head? Short quadrant 2. Anyone need explanation about the short triangle in quadrant 2? Of these? Sure. Ask and you will receive. 17 pi over 6. Oh no, let's make it harder. Let's go 3. What?
For B.
R, yeah?
There's why is there 3 like little segments there and there's like 2 and there's
Oh, good question. All right, so do you get the denominator of 6, which gives you 6 arcs in the bottom? Visually, yes? Okay, so if I don't have anything here, I know I have to go 1 arc up, correct? The problem is that when I draw my big green unit circle like in the beginning, aren't there 3 locations here? How far up do you go out of the 3 of the unit circle? I'm only going up to the first one. Because technically, I can't do this. That's really the thirds. The 45 doesn't exist when you're counting. But when you look at a unit circle, they often have all of the dots there, and I want to make sure you go to the first one, which is the short triangle in quadrant 2. All right. Here we go. Good times. Oh, wait, 17 pi over 3. Forgot that one.
Is that positive or negative?
What, 17 pi over 3? Big old positive. All right. So this would be probably one of the hardest ones that we have done to this point. That was chosen on purpose. 17 pi over 3. Am I going in a positive up direction or a down? Up. So remember when we're counting, we're going in this direction. I've got 3 parts per semicircle. And I'm literally going to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Or, does that make sense? Full revolution, and then 5 pi over 3? Yes? Same idea? But remember, we're always talking about a fraction of 2, which means we double the denominator when we're dealing with these. Which leads us perfectly into the new topic, so I'm so glad you asked for that. That was the perfect segue. Here we go. What I just wrote on the board there, 17 pi over 3, is an example of a coterminal angle. This is 17 pi over, well, that looks like 11, but it's 17 pi over 3. It's also the ending location for 5 pi over 3, isn't it? When I say what is the difference, I don't mean to subtract. I'm asking the question, what does a radian value of 5 pi over 3? How is that different than a radian value of 17 pi over 3? They end at the same spot. What makes them different? Right, the 17 has more revolutions to it, rotations. So that's why we call that coterminal. It means it has the same ending side, but how you get to that ending side is different. You could have turned in a negative direction and ended up there. 17 pi over 3 is coterminal with 5 pi over 3. So the next activity we're going to do is we're going to take a given value and we're going to find coterminal angles. So let's start with degrees because most people really like that. 150 degrees is that location on the unit circle. We're all good with that? Okay. What if instead of going just this little purple arc, what if I did a full revolution and then did the purple arc? How many degrees is that? 150 plus 360 is 510 degrees. 510 degrees is coterminal with 150. That's just random that the 5 and the 1 and the that they were opposites. That doesn't normally happen. Okay? Now, what if instead of that, there's my purple arc for the 150, what if I started here and I rotated this direction? How many degrees is that? Negative what? 360 minus 150. Mental math. Negative 210. Okay. I would get that by taking 150 minus 360 manually is negative 210. So what we're seeing here is the concept of coterminal angles. You take your angle and you add and subtract revolutions of 360. Make sense? Does anyone have a question? Because I can't go to radians if you don't get that. I erased the red one already. The red one would be taking this and going all the way around and then coming back to end at the same spot. Full revolution plus, and then subtraction. Are we good? Yes? All right, so now we did this in degrees. We understand to add and subtract full revolutions. How about in radians? How much is a full revolution? If I start here and I run one full lap, how far is it? 2 pi. This is where that warm-up came into play from yesterday. If I have 5 pi over 6, I'm going to add a revolution. How much is that? 2 pi. So what's your answer? 5, 6 plus 2 is 5, 6 plus 2 in your head, not in your calculator. 17 pi over 6. 12 over 6 is 2. 12 plus 5 is 17. Mental math, good. So 510 is the same thing as 17 pi over 6. And then we go to orange, and orange says, well, I'm going to take 5 pi over 6, and I'm going to subtract 2 pi. Gives me what? Negative 7 pi over 6. All right, here's your opportunity. Everybody close your eyes. I'm going to ask you a question. Close your eyes. I won't throw anything at you, I promise. Keep your eyes closed. How many of you are at a 3, a 2, or a 1? Same scale we always use. How many of you are at a 3, 2, or 1? Raise your hand with your number for the degrees. You understand coterminal degrees. Okay, thank you. All right, now keep your eyes closed. How many of you are at a 3, 2, 1 with radians? Coterminal angles with radians. Okay, open your eyes. Those of you who are at a 2 or a 1 with either of them, can you frame questions so that I can help you, so that you can do your homework? Because there's a lot of questions about this in the homework. Take a minute to think about what or where you got lost. Coterminal angles are so important to the unit circle. I really want you to get it, so please ask. No stupid questions, no faces. Go ahead, Dalton.
With 5 pi over 6 plus 2 pi, you just, like, how did you get 75?
Okay, so 5, 6 plus 2. What if I wrote that? Does that make sense? You good? All right, anybody else? Framing questions. There were 2s and 1s. Go ahead.
I'm having trouble with this one where 5 pi over 6 is.
Okay. So, first of all, 5, 6 is less than 1, correct? The fraction?
Yeah.
So you know it's got to be in quadrants 1 or 2. Right? Because it's not 1 pi, it's less than 1 pi. It's 5/6 of pi. So then the second thing you want to see in your head is the denominator is 6. That's 3 arcs and 3 arcs. Can you see that in your head? Because it's got to be 6 pieces of pi. So you're here, and you're going to see 3 arcs, and you're going to see 3 arcs. 1, 2, 3, 4, 5, 6. Starting from here, you're traveling 1, 2, 3, 4, 5 of them. Yes? Okay, another way you could do it, which may help you out, is pi over 6, 180 divided by 6 is 30. That's quick math, right? You can do that in your head. 5 30s is 150 degrees. That's 150. 30 degrees shy of 180. Yes? Other questions? Framing questions? Anything? Think about it. Let it sink in. For some of you, this homework is going to be this mechanical. You're going to add and subtract 360. You're going to add and subtract 2 pi by hand. You're going to go back and say, well, that's what my note says, and you're not going to make that connection yet. You will. But if there's something, ooh, can you move that water? Do you see that flashing? Is it like a camera on me? You will get there. So now let's go some more nuts and bolts of the unit. What? We're not done? No. No. That's what everybody says at this point. All right. Find 2 positive and 2 negative coterminal angles. Okay, nuts and bolts. 135. I want 2 more positives. So what do I add to 135? Okay, take out your calculator. We can use our calculator. Thank you, Mrs. Connor. Yes. All right, so 135 plus 360. 495 plus another 360. 855. That's a whole lot of revolutions. Okay, 855. Now I want 2 negatives. So take 135 minus 365. Negative 135, negative 225. And then negative 585. Okay, so you're going to be like, oh, those are easy. I get those. Add and subtract revolutions or 360 degrees. Did you know your calculator does fractions? What? It does do fractions. So what we're going to do here, though, is you can't put pies in the calculator. You have to just do the fractional parts. So you're going to be taking 1/9 and adding what number to it? Plus 2. What's 1/9 plus 2 as an improper fraction? Because we don't write that it is 2 1/9. What is it? 19 over 9. Don't forget your pi. What's 19 over 9 plus 2? 18 plus 19, 37. It's not 3, 37 over 9. Okay, you can put it in. 19 divided by 9 plus 2, enter, fraction, convert, and go from there. Good? Questions? In your calculator? Well, now we're going to subtract. So here's our 2 positives. So now we're going to take 1/9 and we're going to subtract 2. So over here I'm going to take 1/9, I'm going to subtract 2. What do I get? Negative what? Negative 17 pi over 9. Take negative 17 pi over 9 minus 2 is negative 35. 87 is 15. Is it 35 or 37? Negative 17 over 9 minus 2. Negative 35 over 9, huh? Oh, yeah, that's right. 7 plus 8 is 15. Yep. Yes. How would you simplify them? They don't simplify. If they did, you could. You should. No. I think not.
Oh, yeah.
Okay? So that's another skill. Last thing. Converting degrees to radians, radians to degrees. What? All right, so here's our big idea. Notice what it says here, by hand, no calculator. So this would be a section of the test that had no calculator, and here's how it works. Tell me something. If I start here and I end up here, I know I went pi. How many degrees is that? 180. So does this make sense to you? 180 over pi is equal to 1, and pi over 180 is equal to 1? Yes or no? Why not?
Like two different things.
Yeah, pi is equal to like 3 point whatever or something. So how could it equal 1?
180 over pi equals 1 and pi over 180? Yes, no? Okay.
They don't.
Yo, true or false? I'll blow your mind. Triangles and squares aren't the same thing. Their value is the same. 180 degrees is the same thing as pi. All right, so for those of you that tuned out, you're kind of doing your own thing. The question was, somebody said, well, this doesn't really make sense because this is 3.14, this is 180. These are what are known as conversion factors. You use them all the time in chemistry, correct? Milliliters, the liters, things like that. You're always putting them on top of each other and saying that they're equivalent items. Here's an example. We know this equation to be true. If I divide both sides by 3 square, I get a 1 on the other side. That gives me this. Same concept over here. Pi over 180 and 180 over pi, they mean 1. They're one and the same. You can substitute pi as 180 degrees and vice versa. So if I have negative 240 degrees and I want to go to radians, don't all of your radians have a pi in the numerator? Multiply by the conversion factor of pi over 180. When you do that, you just have to reduce correctly. So by reducing correctly, negative 240 over 180, the 10s cancel. What is 24 over 18 reduced to? Negative 4 over 3 with a pi in the top. Conversion factors. 180 over pi or pi over 180. If I look at 5 pi over 6 and I want to go to degrees, who does not belong? What part of the fraction is wrong for degrees? What do degrees have pi in them? No, which means I then have to choose 180 over pi because what happens with my pi's? They cancel and go away. 180 divided by 6 is 3, 30. So this is 150 degrees. Final answer. All right, so those of you that tuned out there for all of that, what questions do you have? I'll go over it one more time for your benefit. If you need help, because you want to raise your hand now and say you tuned out. But seriously, what's up here that's confusing? Everything. Yes.
Negative 240 is negative 240 equal pi over 180?
I'm multiplying by 1, changing the form but not the value, because 1 is the conversion factor.
So negative 240 is that. So that would be.
All right, negative 240 would be right here, correct? 30 degrees off would be the tall one, going all the way around.
Okay.
Does that make sense to you? Okay. So then they're saying negative 4 pi over 3 would be 1 arc, 2 arcs, 3 arcs, 4 arcs. It's the same location. I'm just converting it to radians.
So, can I just figure that out when we do
Well, you can if they're unit circle values, but I could give you ones with denominators of 8 or 7 or 9 that are not unit circle values. So that's why we're going to use conversion factors. Question? Prerequisite, remember the idea of fractions. If you're multiplying, everything ends up top, and then everything ends up at the bottom. Remember that? It's fraction times fraction. These canceled. This reduces to 30 degrees. 180 divided by 6, 5 times 30. Yes? I think we did it with a lot more letters at the time. But that's why this is where it was going to come in. Converting between degrees and radians. We did all this. I just explained all that. All right, now these are my favorites from geometry because you remember this. Which is bigger, complementary or supplementary? Which is bigger, complementary or supplementary? Supplementary, right? You take supplements to get bigger? Thank you. And most of the time we compliment people for being small. At least that's been my experience. Not that I've gotten a lot of compliments at 6 foot tall, but in general, complementary is smaller, supplementary is bigger. Complementary adds to 90, supplementary adds to 180. We are now going to extend that definition to radians. So, as you can see, complementary angles add to 90 or pi over 2. It's radian equivalent. They add to 180 or they add to pi. Remember, pi means 1 pi. 1 pi. All right, here we go. Calculator. How do I find the supplement and complement of each? So I gave you DMS, guess what you get to give me? DMS, so use your calculator. Find the complement. The complement. Put it in, 90 minus blah, blah, blah. Make sure your answer is in DMS. 180 minus blah, blah, blah. Make sure your answer is in DMS. $74, $39, $30. And I want DMS. How do you tell the calculator to get for DMS? Yeah. Yeah, the angle, not the answer to DMS. You should get the same thing I have. Yes? 74, 39, 30? Yep. Put in your notes so you don't forget. Okay? Because think about it, what I gave you was about 15 degrees, which is about right here. I want to know the complement. I want to know this size of this angle. So you subtract. Alright? And then your supplement is going to be 164, 39, 30. You can do it in your head. Yeah, that's how I do it too, but most people, when they see DMS, they want to go to the calculator. So that's fine.